Hello everyone, my name is Alvan Aral Baluk. In this video, I will explain the implementation of recursion using two programming languages, Python and C#. The purpose of this project is to understand how recursion works through several case studies, namely counting element in a list, palindrome checking, geometry series calculation, and binary search. Before discussing the code, recursion is a programming technique where a function calls itself repeatedly to solve a smaller version of the same problem. In recursion, there are two important components. The first is base case, which stops the recursion process, and the second is recursive case, where the function calls itself again. Without a base case, recursion will continue infinitely and cause an error. First, I implemented a recursion to count the number of elements in a list. In Python, the function begins with hitung element list. The parameter list itself represents the list to be processed. The first condition checks whether the list is empty using length list equal 0. This is the base case. If the list is empty, the function returns 0 because there are no elements left to count. Next, the recursive case is written as return 1 plus hitung element list 1. Here number 1 represents the current element being counted. List 1. Create a new list excluding the first element. The function keeps calling itself until the list becomes empty. For example, with input 1, 2, 3, 4, the calculation becomes 1 plus 1 plus 1 plus 1 plus 0. The final result is 4. After implementing recursion on a simple counting problem, the next case study is string processing as using palindrome checking. In this case, recursion is used to determine whether a word is palindrome. A palindrome is a word that reads the same forward and backward. The function starts with palindrome check s. The base case checks whether the string length is less than or equal to 1. If true, the function returns true because a string with 1 or 0 character is always a palindrome. Next, the program compare the first and last character using s0 equal s minus 1. If both characters are equal, recursion continues by calling palindrome check 1 minus 1. This removes the first and last character, checks the remaining substring. If the characters are not equal, the function immediately returns false. For example, the word katak returns true, then the word Python returns false. After applying recursion to string validation, I then implemented recursion in mathematical computation using geometric series. In this section, I implemented both recursive and iterative approach to calculate geometric series. The recursive function is direct geometry recursive n. The base case is if n equal 0, the function returns 1 because 2 to the power of 0 equal 1. The recursive case is return 2 multiple n plus direct geometry recursive n minus 1. This means calculate 2 raised to n, then add the recursive result of n minus 1. This creates the pattern until it reaches the base case. I also implemented an iterative version for comparison. In the iterative approach, variable total is initialized as 0. A loop runs from 0 until n. Each iteration adds 2 multiple I to total. Both methods produce the same result. For n equals 5, the output is 63. This demonstrates that recursion and iteration can solve the same problem with different approach. Recursion is more elegant conceptually, while iteration is generally more memory efficient. After exploring recursion in mathematical calculation, the final implementation is binary search, which is a search algorithm. Binary search is used to find a target value inside a sorted array efficiently. The functions start with binary search r target low high. The parameter r is the sorted array, the target is the value to search, low and high define the search boundary. The best case check if low more than high. This means the search space is empty, so the function returns into -1, including that the target is not found. Next, the middle index is calculating using mid equal low plus high. The program compares the middle value with the target. If both are equal, the function returns the index. If the middle value is greater than the target, recursion continues on the left half. Binary search r target low -1. Otherwise, recursion continues on the right half. Binary search r target mid +1 high. This process repeats until the target is found or the best case is reached. For example, searching 7 returns index 3 and searching 6 returns -1. Then, after implementing all case studies in Python, I also implemented the same logic using C# to compare how recursion works across different programming languages. Although the syntax is different, the core concept of recursion remains the same. First is counting element using C#. In C#, the function is defined as hitung element list int list. The parameter list represents as list of integer. The base case check if list count equal 0, mean if the list is empty, the function returns 0. This means there are no elements left to count. The recursive case is written as return 1, hitung element list get range 1, list count -1. Here, number 1 represents the current element. Then get range 1, list count -1. Create a new sublist excluding the first element. The function continues calling itself until the list becomes empty. For the example, For example, 1, 2, 3, 4 becomes 1 plus 1 plus 1 plus 1 plus 0, which result in 4. After counting element, the next case is palindrome checking using recursion. In this case, the method palindrome check is string s is used. The base case check if s length low or equal than 1. If string has 1 or 0 character, it is automatically a palindrome, so the function returns true. Next, the program compare the first and base character, so s equal s length minus 1. If both characters are equal, recursion continue by extracting the middle part using substring 1 s length minus 2. Then the function calls itself again with the new substring. If the characters are not equal, the function immediately returns false. For the example, for the word radar, returns are true. Then, for the word Python, return false. After string processing, recursion is also applied in mathematical computation using geometric series. In the C#, the recursion method is direct geometry recursive integer n. The base case is if n equals 0, then return 1. This is because 2 to the power of 0 equal 1. The recursive case is return 1 lower than n plus the geometry recursive n minus 1. Here, if 1 lower than n, it's a bitwise shift operation, which is equivalent to 2 raised to the power of n. The function then calls itself with n minus 1. This creates a summation patterns. I also implemented an iterative version comparison. In the iterative method, a variable total 0 to m. Each iteration adds 1 lower than e to total. Both methods produce the same result for an equal 5. For n equal 5, the result is 63. The difference is recursion use function call and call stack, and iteration use looping and is more memory efficient. Finally, recursion is applied in searching algorithm, which is binary search. In the C#, the method is defined as binary int r, integer target, integer low, and integer high. The parameters are r as the sorted array, target as the value to search, low and high as the search boundary. The base case check if low more than high, then return -1. This means the search space is empty and the target is not found. Next, the middle index is calculating using integer mid, low plus high high minus low. This formula is safer than low like high because it avoids integer overflow. If the middle value equals the target, the function returns in the index. If the middle value is greater than the target, recursion continues on the left side. Using binary search R target low, mid, minus 1. Otherwise, recursion continues on the right side. Using binary search R target mid plus 1 high. This process continues until the target is found or the best case is reached. For example, searching 7 returns index 3 and searching 6 return minus 1. Overall, the C# implementation follow the same recursion principle as Python, but with the strict typing and more explicit structure. C# also provides additional control and optimization, such as safer index calculation and efficiency operation like bitwise shifting. The key idea of recursion is breaking a large problem into smaller subproblems until reaching a stop condition. Based on all case studies, recursion can be applied to various problem types, including counting problem, string processing, mathematical calculation, tracing problem. Recursion is powerful and elegant, especially when solving problems with repetitive structure. However, recursion also has limitations such as higher memory usage due to call stack allocation. In conclusion, understanding recursion is essential because it's building strong problem-solving skill and algorithm thinking. That is all for my explanation. Thank you for watching.